Hello, my name is Kori Prins, and this is my individual video presentation for Montrose State University CYBR 332-50. I will be presenting on application security testing types and why you should use them and the different most common methods used for application security testing. For application security testing, it's becoming more and more of an important need for developers to properly test their code and applications prior to moving them into production. A few reasons for that being, in particular, websites experience an average of 94 attacks per day. And US data breaches have gone from 447 in 2012 to over 1,800 in 2022. And 26% of those breaches occur from web applications. An average cost of a data breach is about $4.26 million. So making sure that your web applications are properly secure to prevent against attackers from breaching your applications is becoming more and more of a requirement in the current day and age. In addition to just publicly facing websites that should be, or web applications that should be protected, non-publicly facing websites should also be protected to prevent lateral movement through your environment. For instance, if a website or web application at your company gets breached, it is possible for an attacker to maybe move laterally through the environment into other web applications to get further in the environment than they could just from the initial attack vector. A couple of, or the three most common or most used application security testing methods are static application security testing, known as SAST, dynamic application security testing, known as DAST, interactive application security testing, known as IAST, and software composition analysis, SCA. Software composition analysis is not really an application security testing type per se, not like SAST, DAST, and IAST. However, it's important to talk about because security or software composition analysis will give a better picture of the libraries that your application are using, as well as the dependencies. And we'll cover that later on in the presentation. Static application security testing, otherwise known as SAST, is an application testing type that scans the source code of your application for vulnerabilities. It generally uses regular expressions and pattern matching to look through the code to determine if there are vulnerabilities present in the code. It's relatively fast compared to dynamic testing and interactive testing, and can usually be integrated in with your CI/CD pipeline in the early phases of development, as well as with your IDE, your development environment application. A few of the pros for SAST are that you can use SAST early in the development life cycle. SAST doesn't require you to compile the code prior to testing. So you can implement it earlier to detect problems earlier in the development life cycle. It also doesn't require any test cases to be able to utilize SAST as well, because it uses pattern matching to look at the code itself. You don't have to have use cases and test cases to be able to identify if there is vulnerabilities in the code. And I talked about many SAST tools have IDE plugins to make it easier for your developers or you as the developer to utilize the SAST. Most IDE plugins will highlight insecure code or code that the SAST believes is an issue within the IDE so that you can identify issues quicker than if you were to say upload the code to an external SAST solution. Additionally, SAST provides the ability to see where in the code an issue was found, usually by highlighting that piece of code in most cases, which makes it much easier to identify where the issue is and fix the solution as well. Some of the negatives with SAST, however, is that SAST traditionally has a fairly high rate of false positives and false negatives. In the past, SAST solutions usually had about an 50 to 80% false positive, false negative rate. But that number has come down considerably in recent times. It's still relatively high, usually about 30 to 50%. But you can usually, mark either the issue as not an issue or, move on from it or verify that it is an issue perhaps in later testing. For the false positives and false negatives, a false positive is usually pretty easy to identify. You can see and it's part of the issue with SAST testing, and the reason it has a high false positive and false negative rate is that it doesn't have the ability to detect context or if an issue is addressed upstream. So you can oftentimes get flags for insecure code that isn't actually insecure, it's just addressed elsewhere in the code. But unfortunately, most SAST solutions do not have the ability to analyze the code as a whole to determine if an issue that it identifies is actually addressed further upstream in the code, or the reason for the issue. It may be working as intended, but still flagged by the SAST tool. Another negative for SAST, sort of a negative, but it is language dependent. So in order to utilize a SAST solution, you have to utilize a SAST solution that works with the language that you're coding in. Most of the common languages out currently, Java, Node.js, Python, Go, Ruby, etc., have SAST solutions readily available. However, some of the more obscure languages may not have many or any SAST solutions available to it. Moving on, the next type is that I want to cover is dynamic application security testing, or DAST. A DAST solution starts externally and throws different types of attacks at your application, kind of blindly. Now, it's kind of blind, but not quite so much. You usually have to configure a DAS solution to utilize certain test cases. You either using fuzz testing to have intentionally malformed data thrown at the application to test its response. You know, does it crash? Does it allow the malformed data to process, or does it reject it like it's supposed to? And it tends to throw common types of exploits as well at an application. You know, if it throws a path traversal attack, for instance, at the application, does it succeed, or a SQL injection or cross-site scripting. DAST solutions tend to be much slower than SAST or IAST because it has to go through each of the individual steps of the application, such as login or feeding the data through the different web forms, etc., in order for the test to be completed. It also tends to, because of that, generate a high, maybe not a high amount of additional network activity or traffic, but definitely some additional network activity and traffic. So you should make sure that you're working with your network team to expect that there's going to be an additional load on the network for this testing. DAS solutions can also be automated and integrated with your CI/CD pipeline to prevent a build from moving to production if it detects issues. However, DAS solutions, because it requires a working application to be running, known as runtime testing, it can only be implemented in the later phases of the development cycle. So if DAS testing identifies an issue, it can make additional overhead or unexpected overhead on your development timelines and budget. The pros and cons of DAS is that DAS tends to have a fairly low rate of false positives and false negatives because you're testing more specifically for the behaviors of the application. So you will be able to see, and that it utilizes test cases so you can see easily, does it pass the test or does it fail the test? And then take action based on that. Another pro is that with DAS testing, it's language independent. It doesn't necessarily care what language the application is coded in because it throws different application attack types at the application to make sure or to see what the behavior is. And it can also catch issues that SAST alone can miss, such as encryption type issues, authentication type issues that looking at the code itself may not necessarily identify. In addition to that, SAST solutions may not necessarily always catch proper input sanitization and how the application is going to behave in that aspect. So DAS testing can catch a lot of those things that SAST just simply cannot. As mentioned before, some of the cons are that the DAS solution has to happen later in the development life cycle, because it requires a functional application or running application in order to properly run its tests against. And again, it can also only detect issues, as mentioned, after the code has been compiled and deployed. Test cases required for each function and route. This is basically stating that you have to know how your application behaves and write proper test cases to execute each function and route in the application in order for DAST to truly do its job. If you miss, in your test cases, if you miss a function or a route in the application, you are basically going to be blind if there is a particular issue on that route or function. As I mentioned previously, it generates extra network traffic. And DAST also does not indicate where in the code an issue was found. So it can identify that, say a SQL injection was allowed to process, but it can't tell you specifically where in the code that function or that piece of code resides that allowed that function to execute correctly. Moving on to the third type, we're going to talk about interactive application security testing, IaaS. IaaS is a bit of a hybrid between SaaS and DAST solutions. It scans internally to the application looking for vulnerabilities, but it also has to do it at runtime. So it does require functional code in order for IaaS to work. It analyzes how the incoming requests interact with the application. So it's able to not only just see if a attack type was successful, it's also able to identify where in the code that success was allowed to happen. In addition to that, be able to provide necessary details to the developers, such as stack traces, which will make it easier for them to retroactively fix the vulnerability. It does also require test cases to test each route and function. But many IaaS solutions also will tell you which routes or functions have been executed and tested and which ones have not yet been tested, which will give you a little bit better ability to know where gaps are in your testing and fix those gaps. IaaS is faster than DAST, but slower than SAST. It finds a nice kind of middle ground between the two. It's still slower because it requires you to run functional tests or unit tests against the application in order to have IaaS perform testing on that piece of code or application. But it doesn't require going through all the different processes of a web application, from login to filling out the web form, etc., in order to test that piece of code. And additionally, it can also be automated and integrated with your CI/CD pipeline, but it happens later in the process, usually around the middle to the end. Again, because it's a runtime testing methodology, it requires functional code in order to be able to test. Some of the pros for IaaS, like DAST, it has a low rate of false positives and false negatives. And like SAST, it indicates where in the code the issue was found. And most IaaS testing tools also provide a bit of SCA, software composition analysis, as well, or integrated in with IaaS solutions. This is where it can identify vulnerabilities in the libraries themselves that are used in the application and the frameworks that the web application uses as well. Some of the cons for IAST is that again, because it's runtime, it has to, it occurs later in the development life cycle than, say, a SaaS solution. So some additional overhead could be incurred to fix the issues, if there are unexpected vulnerabilities found in testing. It can also, like DAST, it can only detect issues after code has been compiled or deployed. And test cases are required for each function route, in order to properly test an application with interactive application self-testing or security testing. Additionally, because the IAST application analyzes the application on a code level, most IAST tools are language dependent. Most of the common languages, also, as mentioned before, of Java, Node.js, etc., have IAST options available. Most of the major companies that deal with IAST tools, LackDuck, Contrast, tend to have multiple agents available for different languages. However, it makes testing a little more complicated because you do have to know which agent or what the language is and install the agent specific to that language. The last thing I wanted to touch on, as I briefly mentioned in the last slide, is software composition analysis. And this is something that is sometimes overlooked in application security testing, which is the libraries that are utilized within the application. Software composition analysis, SCA, goes through and it helps identify the libraries that are not just added directly or direct dependencies for the application, but also transitive dependencies, otherwise known as indirect or nested dependencies. Those are libraries that are added in because another package has as a dependency. Python, Node.js, both those tend to be very common for that to occur, where a package will have nested dependencies and it'll all get loaded into the application as it's logged. Software composition analysis also tends to be able to check all the libraries that are loaded into the application against one or more CVE databases to determine if the library happens to be vulnerable, what vulnerabilities are logged against that open source library. And if there are any fixes for that, was the CVE addressed in a later version of that library, and what version, fixed the issue. As I briefly mentioned, that functionality only usually works against open source libraries. Private or self-developed libraries that have been released to the public, or that have any CVEs logged against a public CVE repository, typically won't have any vulnerabilities associated to it. So private libraries typically don't have or SCA doesn't usually have the ability to scan private libraries to determine if there's vulnerabilities within them. One other thing that SCA tends to be able to, or most SCAs are able to do, is check against or check which open source license is applicable to an open source library as well. And then flag which libraries use a license type that you don't want to use, such as copyleft style licenses. Copyleft style licenses are licenses that require you to provide any source code that is in your application where a particular open source library that uses a copyleft license was used. Now obviously in a corporate environment, enterprise environment, you wouldn't necessarily want your proprietary source code out there and available. So many corporations tend to frown on libraries that utilize a copyleft license. In conclusion, we covered the three primary application security testing methods: SAST, DAST, and IAST. We covered what software composition analysis is and its functionalities to identify library dependencies, identify open source licenses on a library, and identify any CVEs on any open source libraries. For SAST, we covered that it is better utilized and is able to be utilized early in the development process, but it unfortunately typically has a high rate of false positives and false negatives, but it is relatively fast compared to the other two testing methods. DAST and IAST both typically are utilized later in the development process, but have a lower rate of false positives and false negatives. DAST typically is the slowest of the three. IAST tends to find a nice middle ground between the two, and in my opinion provides the best of both worlds between a SAST and DAST solution. As with pretty much all computer security, only you should utilize multiple testing methods for full end-to-end security testing for the application. You should never rely on one particular methodology or tool simply because it's a single point of failure and doesn't really cover events in depth. This concludes my presentation, and I thank you for your time.